Class 11 Chemistry. We were discussing Unit 7 Equilibrium, and in this video we will discuss about factors affecting equilibria, and we will discuss the effect of inert gas addition, effect of temperature change, and effect of a catalyst on the equilibrium. First come to effect of inert gas addition. If the volume is kept constant and an inert gas such as argon is added which does not take part in the reaction, the equilibrium remains undisturbed. Clear? Two condition is there. Volume is constant and whatever the gas we are adding, it will not take part in the reaction. In such situation, there is no change in the equilibrium. Equilibrium remains undisturbed. Why? It is because the addition of an inert gas at constant volume does not change the partial pressures or the molar concentrations of the substance involved in the reaction. The reaction quotient changes only if the added gas is a reactant or product involved in the reaction. Okay. Now, effect of temperature change. Whenever an equilibrium is disturbed by a change in the concentration, pressure or volume, the composition of the equilibrium mixture changes because the reaction quotient QC no longer equals the equilibrium constant Kc. In the previous video we have discussed the effect of change in concentration and effect of change in pressure. Okay, when we change the concentration or pressure, QC will change, and if we compare with the Kc, then it may be reaction may be go in the forward direction or in the reverse direction depending on what type of changes we are doing. Okay, but when we change the temperature, value of equilibrium constant, that is Kc, changed. Remember it. Only temperature change the magnitude of Kc. Change in concentration, change in pressure will not change the magnitude of Kc. Okay. For a particular reaction, Kc is constant at a given temperature. If we change the temperature, Kc will change. The equilibrium constant for an exothermic reaction, that is negative delta H, decreases as the temperature increases. The equilibrium constant for an endothermic reaction, that is positive delta H, increases as the temperature increases. Okay. Temperature changes affect the equilibrium constant and rates of reactions. Now consider one reaction, N2 plus 3H2 converting into 2NH3, and for this delta H is minus 92.38 kilojoule per mole, and from this sign of delta H we can say then this is an exothermic process. Now dear student, again remember, when we consider reversible reaction, if a reversible reaction is exothermic in the forward direction, then it will definitely endothermic in reverse direction. Okay, and when we represent the reaction like this, that is thermochemical equation is this. So this delta H is for forward direction, and in this case this forward reaction is exothermic. That's why this reaction is endothermic in reverse direction. Okay. According to Le-Chatelier's principle, increasing the temperature shifts the equilibrium to left. Now again, when we increase the temperature, according to Le-Chatelier's principle, reaction will go in that direction where temperature is decreased. Okay. Now, especially in this case, in the forward direction, this is exothermic, and in the reverse direction, this is endothermic. So, when we increase the temperature, this will go in the endothermic direction, that is in the left side,
in the reverse direction. So there is a decrease in equilibrium concentration of ammonia. In other words, low temperature is favorable for high yield of ammonia. Yield means amount, high quantity of ammonia. But practically, very low temperatures slow down the reaction, so we use moderate temperature and catalyst. Okay. Now again, if we see the effect of pressure on this reaction, what is the effect of pressure? We have discussed in the previous video. Okay. When we increase the pressure, equilibrium will shift in that direction where number of gaseous moles are less. Okay, so in this case, high pressure favors the formation of ammonia as number of gaseous moles are less in the product side. Okay, now let us see one more example. Effect of temperature on equilibrium can be demonstrated by taking NO2 gas, which is reddish brown in color, which dimerizes into N2O4, which is colorless. Now, this what is the meaning of dimerizes? Okay, dimerizes means two molecules of NO2 will combine and they form one molecule. Okay. Di means two, mer means unit. Two units combine and form a single unit. This is the meaning of dimerization. And this can be represented like this. 2NO2 converting into N2O4, and for this delta H is minus 57.2 kilojoule per mole. From this sign we can say in the forward direction this reaction is exothermic. Okay, so we can say that is N2O4 is stable at the low temperature and NO2 is stable at the higher temperature. Now, let us see this diagram. This is one flask, okay, and this in this flask, when it is kept in the ice bath, it is colorless because N2O4 is present, okay, and this flask is kept in the boiling water, and in this case, this NO2 is there and its color is a reddish brown because NO2 is stable at the higher temperature and N2O4 is stable at the lower temperature. Okay, and when these both flasks are kept in a beaker that contains the water at 25 degrees Celsius, what change we will observe in the color? Okay, see the flask which was colorless. Now in that flask some pale brown color will appear. Why? Because from ice bath to 25 degrees Celsius, temperature is increases. So this N2O4 will convert into NO2. Okay, and when this is kept in this, we can say this reddish brown color is decreases. Why? Because when temperature is decreases, this NO2 will convert into N2O4. And after some time, we will get the constant color in both flasks. This also explains that equilibrium can be achieved from either side, from NO2 side or from N2O4 side. Is it clear? At low temperatures, formation of N2O4 is preferred and high temperature favor the formation of NO2. Okay. Effect of temperature can also be seen in an endothermic reaction. This is COH2O6 3+. Okay, this is a one compound of cobalt which is pink in color. Okay, and this is Cl minus chloridine. It may be HCl or it may be NaCl which is colorless. When we mix these two, this complex is formed COCl4 2- which is blue in color. Okay, and this reaction is endothermic. At room temperature, the equilibrium mixture is blue due to the COCl4 2-. When cooled in freezing mixture, the color of the mixture turns pink due to shifting of equilibrium in left side. So this COH2O6 3+ is formed. Okay, now again try to understand. When we are decreasing the temperature, according to Lee-Chatler principle,
equilibrium will shift to increase the temperature. And in which direction temperature will increase? You can say this reaction is exothermic in the backward direction. Reverse reaction is exothermic. Okay, so this blue colored compound will form this pink colored compound. So when we cool the mixture, color of the mixture turns pink. Okay. Now effect of catalyst. First of all, what is catalyst? A catalyst is a substance which increases the rate of reaction without itself undergoing any permanent chemical change. Okay, this is a catalyst. Okay, before we discuss the effect of catalyst, let us discuss the progress of reaction. Progress of reaction. Okay, just we can say this is, suppose this is the reaction coordinate. Okay, and this is energy. This is the energy, and this side we are taking the reaction coordinate, and these are the reactants. When reaction is taking place, these reactants will form a one transition state of higher temperature, and then this transition state will decompose to form products. Okay, this is a reaction profile diagram for any reaction. Okay, reactants will convert into the transition state which are higher, which have higher energy, and that will decompose to give the products. Okay, we can say this is the one energy barrier to cross, to convert reactants into products. Now when we add the catalyst, what will happen? When we add the catalyst, this energy barrier will decrease and reaction will follow the new path. Also we can say if we add the catalyst, then this becomes like this. If we represent it by dot, this energy is decreased. Okay, actually this difference, this to this, okay, this difference is known as activation energy. This is the minimum energy which is supplied to the reactant to cross the energy barrier. And when we add the catalyst, this activation energy is decreased. Okay, so when we add the catalyst, what will happen? Catalyst increases the rate of forward and reverse reaction that pass through the same transition state and does not affect equilibrium. Okay, it will not change the equilibrium composition. It simply achieve the equilibrium earlier. Okay, in the presence of catalyst, equilibrium achieved earlier. Catalyst lowers the activation energy for the forward and reverse reactions by exactly the same amount. Catalyst does not affect the equilibrium composition of a reaction mixture. It does not appear in the balanced chemical equation or in the equilibrium constant expression. Same diagram is already drawn. This is potential energy, this is the reaction coordinate, these are the reactants, and these are the products. In the presence of, in the absence of catalyst, that is reaction path without catalyst, this is the reaction path without catalyst. Okay, or we can say this is the energy of activation. And when we add the catalyst, then it will follow the different path, reaction path with the catalyst, this one. Okay, now in this case, this is the lower energy of activation. So we can say in the presence of catalyst, activation energy for both the side reactions is decreased. So equilibrium achieved earlier. Now consider the one example, Haber process of manufacture of ammonia. This is N2 plus 3H2 converting into 2NH3, and this iron is a catalyst. And delta H is this. This is an exothermic reaction. In accordance with the Lee-Chatelier's principle, the optimum conditions for the production of NH3 are high pressure favor the formation of ammonia, so a pressure of about 200 atm. Low temperature favor the formation of ammonia, but at the low temperature rate of reaction is slow. That's why we use the moderate temperature of about 700 Kelvin. And use of catalyst such as iron. Now, similarly, in manufacture of sulfuric acid by contact process, this
is the one of the reaction taking place in this contact process. SO2 plus O2 converting into SO3, and for this Kc is 1.7 into 10 to the power 26. This is a very high value, and this value of K is suggestive of reaction going to completion, but practically the reaction is very slow. So platinum or divanadium pentaoxide V2O5 is used as catalyst to increase the rate of the reaction. Clear? This is the effect of temperature and effect of catalyst on the equilibrium. Thank you. Subscribe my channel to get the next video from this chapter.